To give the impression of light passing through haze, smoke, or fog, we can use an atmospheric effect called a volume light. I've got a very simple scene here with only a single key light. I've got a photometric spot shining on the sculpture. Let's add a volume light, select that spotlight, and go to the Modify panel. It is a spotlight, and I am using the same attenuation values as we previously did in the course. And once again, it's a disc shape with a radius of 0.15 meters. Scroll down a little bit farther in the Modify panel till you come to the Atmospheres and Effects rollout. Click the Add button, and in the Add Atmosphere or Effect dialog, choose Volume Light and click OK. Now the light has been connected to a volume light effect in the Environment and Effects dialog. We can shortcut to that by just selecting Volume Light in the Modify panel and then click Setup. And that launches Environment and Effects. It would be the same if we had gone to the rendering menu and chosen Environment here. Scroll down to the bottom of the Environment dialog, and Volume Light has been added and selected in the Atmospheres list. Here we have the ability to enable or disable the effect, and of course adjust its parameters. The light has already been assigned here. It says Volume Key Light here, and that's the name of my spotlight. We could also add the volume light here in this dialog using this button, and then pick a light in the scene using this button. Let's adjust the volume parameters. These default values are actually going to work for us pretty well. The density is the thickness of the fog. Max light and min light refer to the brightness of the fog. And this is saying where the light is its brightest, we will use a brightness of 90% for the fog. And where the light is dimmest, we will use a fog value of 0. And it's very important that this value, min light percent, be 0. If it has a non-zero value, then your whole frame will fill up with fog. The only thing I want to do in this section is enable exponential, and that will give us a little bit more realism in the fog cone here. So it will actually be not as bright in the center as it would otherwise, and that'll make it a little bit more realistic. The attenuation color and attenuation mult and this stuff doesn't actually work with photometric lights, so we'll skip that. The sample volume percent here refers to the quality of shadows, and I'm going to leave it at automatic, but if you want to increase the quality of shadows and make them less grainy, you could enter in a value here manually. Then we come to the attenuation section, and this is a little bit non-intuitive. These attenuation start percent and end percent are multipliers for the light's attenuation values. Back in our light over here, we have attenuation start and end, and those correspond to these values here, start percent and end percent. This value will multiply against this value to determine where the attenuation of the fog will begin and end. If the attenuation values are both at 100%, then the attenuation values in the light will determine the start and end point for the fog attenuation. However, because again, this is a photometric light, things are a little bit different. In fact, the start percent has no effect here whatsoever. The start attenuation for the fog will always be at the location of the light. Zooming in here in the top view, we're going to have fog begin at the light, and the fog will start to fade out right at that light position, regardless of this value, regardless of this value. The fog end percent is currently 100%, meaning that exactly at the far attenuation end distance, the fog will fade out to this level, which is 0. Okay, these are actually pretty good values. If I wanted the fog to fade out more quickly, I could reduce this end percent. If I set it to 50%, then the fog would not fade out here at the end distance here, but at half that distance, so our fog would fade out here. If we gave this value something above 100%, you would think that might extend the fog out, and it does increase the brightness of the fog, but the fog will always be cropped at the far attenuation distance for the light. Okay, so again, these are pretty good values. I'm going to leave those as they are. Scrolling down a little bit more though, I do want to add noise to make it look like there's maybe a little bit of dust in the air. I'll enable noise, turn it on, set its amount to 0.85. For the type, I'll choose fractal, and that'll give us a more interesting pattern. To break it up even more and make the pattern smaller, I can increase the number of levels or iterations. Set that to 4. The overall size of the noise should be lower. If I want dust, I want the size to be pretty small, so I'll set the size to 0.1. Then we come to the noise threshold, and this will effectively crop the dynamic range of the noise. And to get a lot of very small, fine particles, I'll bring the high threshold down to 0.1. And then we come to uniformity, and this will affect the shape of the pattern of noise. Negative values will cause it to be more broken up and dust-like. I'll set the uniformity value to negative 0.5. Now, of course, I experimented a lot and did several test renders to arrive at these values, but this should work pretty well for the current scene. We can close Environment and Effects, open up the Render Setup dialog, make sure that we're rendering the physical camera view, and in Global Illumination, I have Indirect Diffuse enabled with a quality of 0.66, and likewise in the renderer, I have a quality of 0.66. Let's do a render with our volume light effect added. Click the render button. In this full screen rendering, if we look closely, we may notice that the radius of the fog does not quite line up with the radius of the light itself. It looks like the radius of the fog is being constrained inside the hotspot of the light. And to compensate for that, we can add a projector map. Back in 3ds Max, in the Lights Modify panel, scroll down near the bottom to Advanced Effects, open that up, and as we did before, we can add a projector map. I've already got that prepared. Let's go to the Material Editor, open that, and I've got a gradient ramp here. Double-click the name to load the parameters, and we've got a radial gradient that is mostly white and then fades out to black here. And we want to assign that as our projector map. Just click from the output of that map over onto the projector map slot in the Modify panel and choose Instance. Because I've carefully set the positions and colors of the flags on the gradient ramp, I've made it so that the radius of the light pretty much corresponds to the radius of the fog. And that's something that I couldn't have done by adjusting the spotlight hotspot and fall off. Because as I was saying before, the fall off value is going to extend beyond the fog. But we've compensated for that by choking the light down a little bit, by narrowing the beam a bit using this projector map. Close the Material Editor, and we can do a final render. So click Render Production. Here's another comparison of before and after adding the volume light. And we can see that we've got a pretty convincing effect of light passing through haze or dust. And that's how to use volume lights to add atmosphere to a scene.